ice sheet is losing mass at an unprecedented rate, which raises concerns about global sea level rise and more frequent and severe storm surges along coastal regions throughout the world. Global climate change is causing increased ice loss of Greenland's coastal glaciers. And the ocean may be playing a larger role in this melting than previously considered. A group of scientists is investigating ice-ocean interactions in two neighboring outlet glaciers on Greenland's central west coast.
Greenland represents a tremendous source of fresh water that is stored on top of rock, on top of land.
The Greenland ice sheet is melting, and that is contributing to sea level rise.
A lot of the big glaciers that drain the Greenland ice sheet drain into the ocean. And so we care about where that glacier melt goes. It might affect global sea level rise. We have to understand the oceans for that. We also want to understand how the oceans actually might affect the glacier stability.
So we have two fjord systems. In the two fjords, the glaciers have been experiencing different rates of acceleration. So one has been accelerating rapidly, the other one has been pretty much holding steady. And the thought is because these are both in the same region, they have similar atmospheric forcing, that some of the answer might lie in the ocean.
To think that the ocean can actually control something that's happening on land, it's not just the atmosphere dealing with it, it's actually some physical process within the ocean, and that we don't understand that process.
An interdisciplinary team of NASA-funded oceanographers and glaciologists began an investigation of these two glacier systems in the summer of 2013.
Long rangers to talk to, put in here.
Emily, Jonathan, and Dave, with the help of other scientists and graduate students, are trying to understand how heat gets transported to the glacier face, affecting melt rates at the ice terminus and altering the stability of the entire glacier system.
We want to know the temperature profiles because the ocean can store a lot of heat. We also want to know what circulation patterns exist. So say the ocean is able to carry some heat to the glacier and we're able to get melt. Well, that's going to be fairly cold water, and so if you don't have a flushing within the fjord, you won't renew that heat at depth. And so we also care about just the general circulation in the fjord.
Increased melting at the ice-ocean interface, known as submarine melting, may be caused by changes in offshore ocean temperatures, internal waves, and a weakening of the ice melange that otherwise helps to stabilize the glacier. Also, the geometry or bathymetry of the fjord could determine how water is transported to the glacier. A shallow sill at the fjord mouth, for example, could trap warm water that flushes against the glacier face.
What's amazing is that it's 12 meters deep right there.
Oh, you guys came over that?
They tried to get through there, and they were like, 12 meters!
So they stopped. How much does this boat draw?
5.5. Most of what we're trying to do there is look at variability that's over the next 2-year period. And so we are just hopeful that everything we put in the water comes back and recorded data perfectly. No mess ups yet!
Because all of the moorings went in so smoothly, we had a lot of extra time where we were able to do CTV and ADCP surveys, so measuring the salt temperature, and from that we get the density of the water as well as looking at the velocity.
These transects provide data to model freshwater plumes or large-scale movements such as internal waves.
So a lot of the water that collects on the glacier tops drains to the glacier bed and then enters the fjords, what we call subglacially. The fresh water, once it's not as heavy as the salt water, so it'll rise really fast. As it rises, it mixes a lot. And so we're interested in that, but we can usually never get as close to the glacier front as we want.
We have a little remotely operated boat that Jonathan was using, put together where it was able to run around and do little CTD casts.
We can't actually take a research vessel, a manned research vessel, up to the face of a glacier because that glacier might calve.
It can get closer to the glacier system, but he's still working on actually getting the capability together to get right up to the glacier face.
This unique piece of research will elucidate the intricate and unexplored dynamics that influence the stability of the glacier systems along Greenland's coast and provide an impetus for further research on the ocean's role in ice melt.